The sun is unpredictable. And this was demonstrated once again a few months ago when NASA recorded the strongest solar flare in almost 20 years. In fact, the event was so extreme that it was felt even at the bottom of the sea and caused considerable disruption to the compass data on an underwater measurement network off the coast of Canada. When solar storms sweep across the Earth, they can throw our technologically advanced world into chaos. But how do these particle storms from space actually form? And why do they sometimes have such dramatic consequences for life on Earth? Today, we reveal the turbulent forces that really lie within our mighty central star, and why we have underestimated the danger of superflares for so long. The Carrington Event, when the sun made history. On September 1, 1859, astronomer Richard Carrington went to his private observatory in Surrey, England, as he often did, to point his telescope at the sun and continue his studies of sunspots. To examine them, Carrington projected the telescope image onto a screen so that the solar disk appeared to be just under 30 centimeters in size. This allowed him to clearly see and sketch the dark spots on our host star. But then something happened that no one had expected, and which was immediately immortalized in the history books of astronomy. Carrington saw two bright spots suddenly form above the sunspots, which then became increasingly intense. Ultimately, the formations merged into a single kidney-shaped light, and the researcher later described the unprecedented observation as follows. I hurried outside to call someone who could witness the event with me. When I returned 60 seconds later, I was disappointed to find that the light had already completely changed and dimmed considerably. But what had Carrington actually witnessed? At first, no one knew. The next day, however, it became clear that the strange spectacle had only just begun. Swirling auroras appeared practically everywhere in the world, so bright that people could read newspapers by their glow. These colorful veils even appeared over Jamaica, the Bahamas, and Hawaii, far from their usual appearance near the poles. But that wasn't all. When telegraph operators touched their equipment to transmit messages, violent shocks ran through their limbs. In some offices, sparks ignited paper on which telegrams were written. Even with the power shut off, the lines remained charged, and messages could still be sent. Since no one knew what had really happened, the strange events caused fear and fascination around the globe. What really happened? A magnetic explosion. Today, scientists know that the so-called Carrington event of 1859 was caused by a massive white light flare, a magnetic explosion on the sun. In tandem with this extremely energetic flash of radiation, the sun also hurled a cloud of charged particles into space. When this immense energy collided with Earth's protective magnetic field, it severely distorted it, allowing charged particles to reach far into the upper atmosphere, triggering auroras and creating phenomena humans wouldn't forget anytime soon. How solar storms arise and why they matter. To this day, the Carrington event remains the largest scientifically documented magnetic storm on Earth. But what exactly are these phenomena? The sun operates on a cycle, a kind of giant pendulum that swings between relative calm and periods of intense eruptions, roughly every 11 years. During these solar cycles, the sun's magnetic field reverses polarity, and even its shape changes. This interplay is driven by massive convection currents inside the sun, especially in the convection zone, which is about 21,000 kilometers deep. Here, the solar plasma rotates at different speeds depending on latitude, while deeper layers rotate more uniformly. These differential plasma movements generate massive magnetic fields with opposing polarities. When these fields discharge, they explode, releasing intense UV and X-ray radiation and causing coronal mass ejections, CMEs. These CMEs launch energy-charged particles into space at speeds up to 3,000 kilometers per second. Normally, the sun constantly sends a steady stream of particles known as the solar wind, which compresses Earth's magnetic field on the sunward side and stretches it into space on the night side. Electrons from this wind flow along magnetic field lines toward the poles, colliding with oxygen and nitrogen, resulting in the aurora borealis. However, when a solar storm hits Earth, the magnetic field becomes far more distorted. Electrons can then migrate to lower latitudes, closer to the equator, making auroras visible in places they're rarely seen. The real danger: solar storms and infrastructure. The stronger the storm, the greater the danger. That's because these particle storms can induce voltage differences on Earth's surface. Electricity always takes the path of least resistance. That's why high-voltage transformers in our power grids are particularly vulnerable. The result: huge currents flow through grounding cables, potentially damaging transformers and causing regional blackouts. The strongest solar storm in almost 20 years. Even before satellites were a thing, solar storms had dramatic consequences. May 1921, a major storm disrupted railways, set phone stations on fire, and collapsed telegraph systems. March 1989, another storm caused a blackout in parts of Canada, affecting 6 million people. But experts believe a violent solar storm today would cause even more chaos. A study in space weather concluded that modern infrastructure, including rail signals, traffic lights, mobile networks, and GPS systems, could be severely disrupted. And in May 2024, we got a preview. May 11, 2024, a super solar storm hits Earth. A G5 class superstorm, the strongest category, hit Earth, causing auroras even in temperate and southern latitudes. It was the most intense solar event in almost 2 decades. But what truly shocked scientists was where the storm's effects were recorded: under the sea. Alex Slimer from Ocean Networks Canada, ONC, had already noticed strange anomalies in March. Their underwater sensors, designed to monitor marine data, picked up disturbances that were later confirmed to be caused by solar radiation. When the May 11 storm struck, ONC Compass data showed significant magnetic anomalies at a depth of 2,700 meters. In shallower waters, like Fulford Passage near Vancouver, the compass readings deviated by up to 30 degrees, an unprecedented discovery. Why we've underestimated superflares. So, is the sun calming down? Not yet. Experts say the peak of the current solar cycle is still ahead, and more storms like May 11, 2024, are expected. Could we face a Carrington Event 2.0? Well, as experts note, the variability of solar activity makes predictions impossible. But here's the worrying part. Recent research suggests we may have massively underestimated the threat of superflares. Astronomers at the Max Planck Institute for Solar System Research examined over 56,000 sun-like stars using data from NASA's Kepler telescope. They discovered 2,889 superflares in 2,527 stars, meaning such events may occur once every 100 years, not once every 1,000 or 10,000 years as previously thought. This drastically changes our understanding of our sun's eruption potential. It could produce solar flares 10 to 10,000 times more powerful than the Carrington event. What can we do? In the face of such power, there's little we can do to stop a superflare. If given timely warnings from solar observatories, the best we can do is shut down sensitive infrastructure, shield critical systems, temporarily suspend operations in vulnerable sectors. And now, you're welcome to shield the subscribe button with a special click. Sun with Face. Become part of our community so you never miss another cosmic update. We'll see you soon.